That's if they're not the first one.
Yeah, but you don't have to. You don't have to balance them or anything like that. You just need to look and say what type they are. So you don't even have to worry about writing that equation. You can just put 1, 2, 3 and what type of reactions they are. We talked about 5. I only had room to put 4 down here. I'm sorry, 3. I can even count 3 down here. And when you get that and you get to check with somebody, then we're going to do notes. And then you also already have your practice because it was synthesis and decomposition together. So we're going to move on to decomposition. All right, so this week, what we got coming up, you only have one quiz, and it'll be on Friday, whenever we're here for just a short period of time. And it'll be over synthesis and decomposition, which are the two that we will have covered. Thursday, we'll cover what are called single replacement reactions, but we won't quiz on those until the following week sometimes. So really the only thing that's going to be open for requiz is the one that we're going to be taking on Friday. So that doesn't really come into play until next week. I still obviously have tutorial times assigned. If you were absent, you missed a quiz, or if you just need to come in for tutorials for what we're doing now in preparation for the quiz and the test as we move on, then please feel free to do that. So that's also all posted in your Google Classroom too. All right. So we're going to move on to your notes. Find them under chemical reactions. We're doing decomposition reactions, which are going to kind of be the reverse of our synthesis reactions. And just like we talked about with synthesis reactions, it's not just a haphazard way that they decompose or break apart. Yes, ma'am. Okay, well, you can go and look for a new set. I think we started them on the 11th, I believe. So they don't just break apart or decompose randomly. It's in that black box. It doesn't have biology on it. And I believe it was the 11th is when we started these, if I'm remembering correctly. So they follow a pattern, just like we saw with our with our synthesis reactions. Is that right? So a decomposition reaction is, like I said, the reverse of a synthesis reaction, because you have a complex compound decomposes into 2 or more simpler substances, usually requiring heat or electricity for that to happen. And we can recognize the fact that it is a decomposition because it has just one reactant. So when you're given a list of reactions, especially if you're given just the reactants, this is probably the easiest one because you're going to always start, you can see, with just one reactant. So there was one of those. You should have had one of those on your journal. What was another one that we had on the journal? There was a giveaway. Nobody knows? Alrighty then. I'm sorry? What first? What was it called? Did anybody get out their notes and look at it?
I put the single replacement.
Okay. But single replacement is going to be a compound plus an element, and it replaces. Was there any of those where it kicks something out of that compound? I kind of chose the easiest ones on that, so hopefully you can go back and look at them. Since I don't feel like people didn't really give it a try, that's why I'm not going over it. So my first one, I have an ionic compound, and it's going to decompose into a metal and a non-metal. So just the reverse of what we've talked about. Don't forget about your diatomics. You come across a lot of them in this and in the ones that we're going to be doing on Thursday. A molecular compound, which is a covalent compound, is just going to decompose back into its non-metals. So that reverse reaction where we've been producing water, so reverse of that would be the decomposition. Some compounds may decompose into an element in a compound. You see that here with hydrogen peroxide, that's what H2O2 is. These are kind of hard, and we probably really won't do a lot of those because they're kind of hard to predict what they're going to do. A metallic carbonate, and remember a carbonate is your CO3 with a -2. So that's my carbonate right here. Metallic just means it's combined with a metal. It's going to decompose into that same metal with an oxygen and CO2. CO2, you don't have to worry about charges. You know how to write that. This is an ionic compound, so you're going to have to check your charges and make sure that you've written it correctly. Next one, metallic chlorates, and these should sound a little familiar, especially if you did some practice over the weekend, because they're just reversing of what we did with our synthesis reactions. So a chlorate is your ClO3 -1. That's your chlorate right there. And it breaks down into a metal chloride and now just oxygen. Next one, metallic sulfite. Sulfite is my SO3 -2. So it's right here. So it's going to decompose into my metal oxide and sulfur dioxide. Next one, if you have a metal hydroxide, your hydroxide is your OH-. It's going to decompose into a metal oxide. So a metal combined with oxygen and water. Next one is your oxy acid. And remember, an acid starts with a hydrogen. And if it's an oxy acid, it's combined with some polyatomic ion. It's going to be decomposed into a non-metal oxide and water. And those we're going to do, if we could do those or you see those, are going to be real simple. I would take my H2O out of here first. And what I have left when I do that is sulfur, of course, and instead of 4 oxygen, I have 3. So that's always going to be my non-metallic oxide. Take your water out, and what is left over will be your non-metallic oxide. So when you decompose that, then it will be balanced once you decompose it. They're not always that simple, but that's kind of how we're going to do them here for us. And, yes, ma'am.
So when you have a acid, so the hydrogen, the H2O would go on this side and you write it all the way out.
No, I just meant that I was taking my hydrogen, my water out, but the water is a product. Is that what you mean? Yeah. I just was kind of showing that take your water out and see what you have left over, and what you have left over would be your non-metal oxide. Okay. And then last one I want y'all to write in is a metallic sulfate. Remember, your sulfate is SO4 -2. It will decompose into a metallic oxide. Wrote too big, plus sulfur trioxide. So an example of that would be calcium sulfate. There's a metal sulfate. Would decompose into a metallic oxide. So my metal is calcium, and I put it together with oxygen for my metal oxide. Calcium's a +2, oxide's a -2, so I didn't need any subscripts. And then also sulfur trioxide. Once again, a lot of these today are going to be really easy to balance if you write them correctly. If you don't write them correctly, then they get a little bit hard. So if you go back and number them, so whenever we look at them, so this is number 9, 8, 6. Y'all can continue on. You should have 9 different types. If you'll number from the very first one down, 9 different types. And that's going to be helpful when we're going to start looking at some. And then we can refer back to them. All right, like we did on Friday, I think. We're going to look at our practice now. So if you're going to do your practice where we've moved to decomposition. So you can tell it's decomposition practice because there's only one reactant. Okay, did you go and look at the days you were missing? Whatever days you were absent should be in there. This should be a pretty big packet because it has synthesis and decomposition. So I know we started Monday. We did that and balancing. So probably maybe the 7th. Let me see. I can't remember the date. Yeah, see, it just messed up the other regular end. I got regular hand on there stuck in there, so sometimes it can get messed up. All righty. So let's go look at some decompositions. So Ben and Yaheen, this is still that practice, same practice, because it had both synthesis and decomposition. All right, so we'll look at this one right, a few of these right here. All right, so number 1, once again, I can tell it's decomposition because it only starts with one reactant. So I need to then see what I have here and match it up. So if I look at this, I have nickel, which is a metal, and ClO3 is chlorate. That's my chlorate polyatomic. So this is a metal chlorate. So what I would go down all of my examples of that. And which one does that match up with? What number on your examples? Number 5. This matches up with number 5 because number 5 talks about a metallic chlorate. And it says a metallic chlorate decomposes into a metallic oxide. I'm sorry, I'm on the wrong one. It decomposes into a metallic chloride. So that would be NiCl2 plus oxygen. Oxygen is diatomic. This nickel, you would have to figure out what its charge is from what it's combined with as a reactant. So a chlorate is a -1. It took 2 of those to combine with that nickel. So that means nickel is a +2 in that compound. So that's why I had to give a 2 to my chloride. So that's going to kind of be your skeleton, and then you have to always balance it. So if I look, let's see what I got. My oxygen, I have 6 oxygen on my reactant side, so I would put a 3 here. And then I think everything else would be balanced. Nickel, I only have 1 on each side, and my Cl, I have 2. And then you have to write it. So it's nickel 2 chlorate yields nickel 2 chloride plus oxygen. That 2 has to be included because it's a transition metal that can have more than one charge. And with that, if it's a +2 on the reactant side, it's a +2 on the product side. They don't change charges as they move across from products to reactants. Also, that is oxygen, neutral oxygen. It's not oxide. So if you wrote oxide instead, that would be wrong. All right, number 2, I have silver oxide. So that's just a metal plus an ion metal. So that's just an ionic compound. So which one does that match up to on our list? Just number 1, right? Our easiest one. So it's simply going to break apart into its metals. So silver plus oxygen, and you have to remember oxygen's diatomic. And then the only thing you would need to do on that one is balance it. I have 2 oxygen on my product side, so I'm going to put a 2 in front of here, which gives me 2 times 2, 4 silver, so 4 here. And then writing it would be silver oxide yield silver. Silver is a transition metal, but it's one of ours that does not have more than one charge plus oxygen, and that would be written correctly. All right, when you get through with that one, then why don't you try number 4? That is iron hydroxide. OH is your hydroxide. So match that on your list and then see if you can decompose it correctly. Josh, thank you. So which one did number 4 match up with? Which number 7? Perfect. So it says a metal hydroxide breaks down to, what do we got? A metal oxide. So what would be my formula for that? Plus H2O. So that's kind of a skeleton. We got to come back and we got to deal with this right here because that's an ionic compound. I got to make sure I've written it correctly, which means you have to go back here and figure out which iron you're using. So did anybody figure out which iron we're using? Thank you. +3. Hydroxide is a -1, and you had 3 of those. So to cancel that out, I had to have a +3. So if that's the case, when I get over here to write this, my formula needs to be 2 and 3. I'll rewrite that so y'all can see it a little bit better. That's what your formula should be. That way I'll have a +6 on one side and a -6 on the other side, and then it will cancel out. So if you don't do that, like I said, with your writing of your formulas, then it's wrong to begin with, so you kind of can't get it ever correct. So then my last thing that I'm going to do is I'm going to balance it. I'm going to do my iron. I'm going to put a 2 in front of here. And then how many hydrogen did that give me? 3, 6, is that correct? I'm going to put a 3 in front of here. And I think in doing that, that also took care of my oxygen, because I had 6 oxygen and now I have 6 because of this, and then my other 3 here. So, there's quite a few steps to these. That's why I said you really need to do some practice, because if you didn't think to write this correctly, then you're kind of lost to begin with. Let's try one more. Let's do number 5 together. Give that one a try. A lot of people, no, I don't see anybody hardly except Ethan with the pink sheet out. Some of y'all might just not be able to see. I don't know how you can do it without your pink sheets. I know y'all don't have all those charges memorized. If you don't have the charges for your ions, then how do you know that you're writing your formula correctly? Amanda, you got all those charges memorized? Oh, you got your pink sheet there. Sorry about that. So which one did this one match up to? Number 4, perfect. And this one's a little bit easier because I don't have a transition metal, so I don't have to try to figure out which one. We know the charge for zinc and we know the charge for carbonate. They're on our ion sheet. So our metal carbonate decomposes into what? ZNO, and that's a +2 and a -2, so that makes it nice and easy. And perfect, CO2. And I don't have to worry about charges on that. And it's also already balanced, right? It's already balanced. And like I said, as you go through these, they should be pretty easy to balance. So if you're really struggling with balancing them, go back, please, and check your formulas. All right, so that's kind of an example of how you're going to have to use your notes for this and synthesis and use it to help you fill out what your products are. So that'll give you a little bit of time today to work on synthesis if you didn't get to it over the weekend, or decomposition. And we will do that tomorrow. I told you I'll give y'all a day to work on it in class. If you're stuck on one, let me know, because if you're stuck on it, probably somebody else is stuck on it too. Ben and Jaheen, we're just going to take some time to work on practice. So y'all can do that, and that's probably what we're just going to continue with tomorrow also.